Hi, everyone. So we're going to be looking at finding the point of discontinuity for a complex function, okay? Now, let's assume we have this function here, f of z equal to cot z. Now, this function involves a cotangent of a complex number z, and we will examine where it experiences discontinuity, okay? Now, recall that cot z is 1 over tan z. And your tan z is sin z over cot z, okay? So therefore, our cot z is equal to cosine of z over sine of z. I think it's very, very simple to understand. That is the inverse of tangent, okay? Now, the cotangent function encounters discontinuity where the denominator, these are denominator, right? Where the denominator equals 0. So now, we look for value. So we look for value of z. So look for value of z where our sin z will be equal to 0. Very simple. Now the sine function is 0. The sine function is 0 when z is an integer multiple of pi. So the sine function is 0 when z is an integer multiple of pi. For example, okay, our z is equal to n pi, where our n is an integer. So therefore, the point of discontinuity, the point of discontinuity for f of z is equal to cot of z. So what that means now is that what that means we will now have our z equal to pi, where n is integer. So we'll have 0 plus or minus 1 plus or minus 2. It continues that way. Now, so basically, these are the values for which the the which the so these are the values for which the denominator sin z becomes 0. And this leads to a vertical asymptote in the cotangent function. Okay, so this is straightforward. It's a very simple problem. So you just need to look at that. So, and these values are, let me repeat here again. These values could be 0, plus or minus 1, plus or minus 2, plus or minus 3, and continue that way. So thank you for your time. You hear from me very, very soon. Thank you so much.